Hello, everyone. Today we are delighted to welcome Michael Keeling, software engineer at Gavi. In this session, Michael will discuss about his book, Design It from Programmer to Software Architect, exploring key challenges in designing software systems. Just before we start, a quick reminder to our viewers, your participation is encouraged, so please leave your questions in the YouTube chat so Michael can address them later. Michael, thank you for coming to our book club. It's all yours.
Absolutely. Thank you very much for having me. Well, good morning, good afternoon, wherever you are. So I am located in Pittsburgh, Pennsylvania this morning. So very early morning for me. So East Coast of the world. Just to give you a little bit of context of where I am. So for today, we're going to go over a couple of quick things. Spend a couple of minutes kind of sharing a bit about myself, just to give you some context of how the ideas in Design It came together. Talk about a couple of the big ideas from Design It. Obviously, not going to have time to go through kind of everything that's in the book, but like to make sure that we hit some of the main points for potential discussion, and then the topic that I've been researching kind of since the book, like what happens if we go beyond what's in Design It. It's been 4 or 5 years since it's been published. How can we kind of bring these ideas to the next level? So talking about whole team software design a little bit as well. All right. So a bit about me. So graduated from Carnegie Mellon University with a master's in software engineering. It's kind of where I picked up a lot of these ideas about software architecture, learning from Mary Shaw, David Garland, and others. Computer science degree from William & Mary. It's been a while, I guess, since leaving those environments, but I think those were kind of foundational things for how I got here. For about 7 or 8 years, worked at a startup that was then acquired by IBM Watson. So working on not the Jeopardy Watson, but the Watson services that are still available, through the IBM cloud. Kind of before the big, I guess, the second wave of AI that's been coming along. We're here to talk about Design It. Wrote Design It. I also contributed a chapter to the Software Architecture Metrics book, which, if you haven't checked out, is a fantastic collection of experience reports and case studies. So pretty cool thing to see. Currently, I'm working at Kiavi, which is the largest fix and flip lender in the United States. Basically, we give loans to people so they can buy old houses and make them new houses and resell them. So I'm the senior most engineer at that company, kind of the tech lead for the entire engineering org is maybe the simplest way to think about that. All right, so I guess I should say the reason I bring this kind of stuff up. So everything that's in Design It, a lot of it kind of came about through my experiences, especially while I was at Watson, kind of building on things. I was learning at university and trying to make them practical in some way, practical and useful for everyday developers. All right, thesis of the book. So kind of during that time, my observation, and really even since then, noticed that on the fast-moving, very resilient teams, you've got multiple individuals who are contributing to the software systems design. It's not just one person kind of holding everything together. On the teams that are moving fastest and kind of dealing with change the best, you've got lots of people who are in play, contributing to the designs, contributing to the architecture. How does this come about for these teams? Like, how do they get to this point? Well, it seems like at some point you kind of get a critical mass of developers who have, this foundational sort of knowledge in architecture and design. Enough people kind of know, the lingo, or they know the key concepts. And then you also see that these teams build up a robust set of methods that they're able to kind of pick and choose when they're needed to apply kind of just in time, really at any moment, right? So when you have enough people who are able to do these things, no one person is then kind of running the show. Everybody is playing a hand in this. Okay, so that's cool. Where do people end up learning this stuff? Well, 10 to 15 years of hard luck, hard work, study, reflection, really working to figure these things out. Most people are going to figure this stuff out, right? Given enough time. It's not, there's nothing new or invented that's in design necessarily. If you're lucky enough, though, to find good mentors, maybe early in your career, maybe you happen to be on the right kind of project at the right time where it's doing something interesting, where you can learn a lot very quickly. Or maybe you're in a fortunate situation where you can maybe leave your job for a couple of years and go back to study at university, something like that. You're going to accelerate these timelines. You're going to learn these kinds of things a lot sooner. Not everybody can do those things, right? And a lot of folks might not be able to get on those like just right in time projects, things like that. So I don't know, a question that I had, a thing that I was trying to solve, how can we accelerate this learning time? How can we kind of smooth things out so that we can get these ideas that are really useful out to more people, and maybe take that 10 to 15 years kind of time down to, I don't know, 5 to 8 years, something like that. So I don't know, that's what I kind of set out to do. So when you're reading this book, kind of the way I look at it, and the way I think you should look at it, is for experienced tech leads. You've been around the block, you've kind of seen these things before. Hopefully, like what the ideas in design it does is it helps you kind of sharpen what you already know, right? So that you can become a more effective teacher, a more effective mentor, right? Maybe there's a few new ideas you pick up, but now you're that kind of go-to person for your team to kind of help level them up, perhaps even better than you were before, right? For early career developers, right, hopefully Design It is a more friendly, direct kind of introduction to these essential skills that you're going to need throughout your career, right? Looking at all the book recommendations that are out there, like it's literally thousands of pages of material that you have to read to kind of bring all of these kind of ideas together. I tried to bring it down to a couple hundred pages of hopefully not intimidating, very inviting material to read. So, the gentle introduction, if you will. All right, so that's all nice. That's kind of big picture kind of context, but let's actually talk about some of the ideas briefly here. All right, so there were really three big things that I wanted to try and get across with the book. Trying to talk about, design thinking as a foundation for how to bring architecture into the discussion and kind of keep it going. Foundational kind of knowledge that was needed, right? So things that you just have to know to be able to, to be effective in designing architecture. And then design methods. So this is all about what do you do, right? So like, how do you actually go about doing these types of things? All right, let's talk about design thinking for a minute here. All right, so there's a lot of different design thinking frameworks out there. This one is adapted from something that I learned from the Stanford Design School. 4 different mindsets for thinking about design. Okay, understand, explore, evaluate, make. The whole idea is when you're kind of faced with a problem or faced with something that you need to solve, something you need to design, one of these mindsets is going to point you towards the right kind of direction, point you towards a way of thinking about the design that is going to help you help move you forward. Okay, so in the understand space, you're really just seeking information. Okay, you're trying to describe the problem, understanding the problem. Okay, you're going to be talking to stakeholders a lot. You're going to be working on kind of empathizing with their needs and kind of summarizing or making more specific, specifying their requirements. All right. Explore. This is probably the one that most people think of when they think of design. Right. You're creating design concepts. You're trying to identify different engineering approaches. You're looking at solving some aspect of the problem. Okay. Yes, brainstorming is a thing that you might do and explore, but seeking different, creating different options and trying to just kind of see what the available solutions might be for problems that you're trying to solve. Okay. some aspect of the problem, not necessarily even the whole thing. You might focus in very narrowly sometimes as well. All right, evaluate. At this point, we're trying to converge thinking, right, and determine the fitness for these potential designs that we might be coming up with. Testing things, okay, checking that they're actually satisfying conditions that we've laid out. When we're doing this, it's always relative to our current understanding, right? So in the process of evaluating, process of exploring, we may end up understanding something new about the problem that we didn't know before. All right, finally, make. So if you're not creating something, if you're not making things kind of real in some way, it's very difficult to share those ideas with others, right? So the make mindset is really about kind of turning those ideas that you might have been talking about into some kind of real world artifact. You know, it could be a sketch. Maybe you start getting into a model, building a prototype, possibly writing out some documentation, something like that, where you are going to take these things that maybe are just in your head or that you're just talking about and making them real in some way, right? So these are the mindsets, 4 different ways of approaching a design problem. And then the other half of this is these principles, okay? Which I call the HEART principles, a bit of a acronym to help remember it. So the human rule, ambiguity rule, redesign rule, tangibility rule, HART. Okay. With these things, what we want to try and do is get you thinking about sort of how to go about these things. These are like the rules that we play by anytime we're doing design, right? So design is going to be social. You can't kind of do this by yourself. You have to talk to stakeholders. You have to bring in your team, right, that you're going to be implementing the software with. The ambiguity rule is all about preserving ambiguity to create options. This one is meant to be a little controversial and get you thinking a little bit here, right? It sounds counterintuitive. Hey, I thought with software architecture, the whole idea was to remove the ambiguity, to specify the things, to make it clear what we're doing. Yes, it is. But a great architecture is also going to be one that, from a design space perspective, is going to create options for you, right? You're going to be able to evolve with the domain, for example, as you're learning more about what that domain entails, right? It's this kind of idea of I don't know, a good ambiguity that you want to be preserving, keeping options open for yourself. Redesign rule. So we kind of have to recognize that all design is redesign. Okay, most of the time, nearly always, we're going to be looking at patterns. We're going to be looking at past architectures. We're going to be applying things from the past, maybe with slight tweaks or a different kind of flavor in a solution that we're working on now. And finally, the tangibility rule, again, like making things real in some way, making them tangible. This is all about trying to facilitate communication, make it better and easier to get ideas, which can be really squishy, and make them very concrete in a way that we can verify or check understanding, or that we can be very sure that the ideas are commonly held amongst a team. All right, so these two ideas together, we got the mindsets and we've got the principles. Kind of that's your basic starter kit for how to go about design. Right. So why is there not a design process? Right. Why is it this kind of loose thing around principles and mindsets? Well, design can be super messy, right? You can be doing it at really any time. The understand, explore, evaluate, make. It might look like a process, but really you're kind of jumping between these mindsets based on the risks in your system, the questions that you have, maybe just whatever you're interested in today, right? To try and solve. They don't go in any particular order, right? You can do them in any way, any order you choose. And in fact, if you feel like your team is getting stuck, you can, roll a die and pick something at random as a way to just kind of reframe yourselves or kind of recalibrate to what you're trying to work on. All right, so that was the design thinking bit. Foundational architecture knowledge is kind of the other piece, right? So now maybe you kind of have the way of thinking about things, but what do you need to know about architecture? All right, so this is I think after a bunch of research, this is kind of what it all distills down to. There's a little bit more to it than this, but this is really the essential kind of foundations, okay? Figuring out how to work with stakeholders, knowing what to do with that, dealing with the architecturally significant requirements, okay, the things that are kind of most influencing the architecture, being able to define and select structures, right? How you're going to arrange things to arrive at the architecture. You got to know patterns, right? If all design is redesign, you need to kind of be aware of a lot of the patterns that are out there and available. The ability to kind of model and diagram effectively. This is about making things tangible, right? So the make mindset and the tangibility rule. Architecture descriptions themselves is kind of how to document these things effectively. Is just a skill in kind of the business world that we really need. And then evaluation techniques. So being able to test these designs in some way. If you have a little bit across all of these things, you're going to be well on your way to being an extremely effective architect. I don't have time to go into all of this today, but I do want to kind of dip into briefly the architecturally significant requirements. All right, so I mentioned this briefly before, but ASRs, architecturally significant requirements, these are the things that most strongly influence the choice of structures for the architecture. These are the things that are basically telling us what the architecture needs to be. Usually we organize these into 4 categories: constraints, quality attributes, sort of influential functional requirements, and then there's a bunch of other things that may come up as well, other influences. Most of these I think are pretty obvious, like functional requirements, sometimes referred to as killer features, right? Something that if your architecture doesn't support, then the whole thing is kind of a failure. Constraints are sort of these pre-made design decisions, right? Things that you choose up front that you're never going to change again. And then other influences are simply just things that are going on. So like the skills in your team, or maybe even the hot technology trends of the day, right? Quality attributes, though, are interesting and probably the most important and difficult to understand one of these ASRs. So when we're talking about this stuff, we're talking about these externally visible properties of a software system. So basically, the expectations for how that system operates. Okay, not just what it does, but how well it does that thing. Okay, it goes by lots of names, and I'm sure you've heard some of these before. The ilities, the non-functionals. Sometimes they're quality requirements. Maybe they're characteristics, system properties. Right, lots of different names. All basically kind of trying to get at the same idea, which is it's fine for your software to do a thing, but how well it does that thing is also important. All right. For quality attributes, the best way to write these things, to kind of capture or describe these things, is as a scenario. So this is kind of the most formal version of that idea. So 6 different parts to it. Something happens in the system to an artifact piece of the system. The software responds in some way, and then you can measure that response, right? And this is all done in kind of an environmental context, right? Most people don't specify like the full kind of formal 6-part sort of scenario, but it's useful to kind of learn that and think about it so that you can start to bend the rules once you know kind of what the complete version of this looks like. So here's an example from a mission flight bit of mission flight software from JPL. The raw scenario that you see up top is kind of the informal description of what we expect, right? So processors and platforms are a variation from project to project. We need to enable projects to select the different processors and platforms with minimal effects to the overall system, right? So we still have to allow for some kind of system optimization happen, but we want that to be a not the main focus of the work that has to be done, right? So with that raw scenario, maybe it gets the gist across, but like, what do you really mean by some of these ideas, right? What is really meant? You might specify like the full kind of formal scenario, something like this, where like the test team needs the ability to run their test suite, right? So that's our source and stimulus on the mission flight control system, the piece of the architecture that we care about. And they need to be able to see their test results without having to actually change the code in some way, right? Without making code modifications, right? And the context for this is we're going to add a new hardware platform. Okay. You can perhaps start to imagine that there are different ways, there are different ways to implement flight control systems in software. But if you want to be implementing this particular requirement of being able to apply the software to different platforms without changing the code, now you need to be thinking about perhaps configuration systems, abstractions on top of these platforms, different things to kind of protect you, right? These are all things that you're going to have to design into your architecture now. All right. Why are these so important? So the same features, right, can be implemented in any number of different ways, right? But when you're talking about design decisions, the majority of those design decisions are going to be determined ultimately by the quality attributes in some fashion, right? Yeah, these are the things. These quality attributes have outsized influence over the architecture, which is why we're talking about it right now. All right. One more example on this point that I think maybe drives it home pretty well. Say you wanted to buy a blender, right? A blender for mixing some drinks, right? Maybe milkshakes or smoothies, something like that, right? So a constraint. Let's say that you have a time constraint, a business constraint that, well, we need it by this Friday night, right? We're gonna have a party. We have to have a blender by Friday night. You could look at some quality attributes like the cleanability, the countertopability, or maybe the portability of this thing, right? So how easily can it be cleaned? How easy is it to move around to take different places? And as a functional requirement, well, it's got to be able to mix, right? It's got to be able to blend, right? That's the only real functional requirement that it has. From these, requirements, we can now look at different blender options that are out there, right? So maybe we would go with the standard kind of blender, right? Or the hand blender, or my all-time favorite, the chainsaw blender with the motorcycle throttle that allows you to control the power that you're putting out to it, which is this is a real blender, by the way, powered by a gas engine. All right, they all blend, right? These all blend, but as you can see, like the characteristics of each of these things, right? The properties that they each have that they promote is very, very different, right? Now we can start to talk about trade-offs. We can do some simple trade-off analysis with these things, right? So maybe the hand blender is the easiest to clean. You just kind of run it under a sink. The chainsaw blender, you've got a gas-powered engine on that thing. It's got the most power. It doesn't require electricity. You can take it anywhere, in the world that you might need to blend. But it's not exactly the quietest in the world, right? And maybe safety is a slight concern, right? You wouldn't want to be using that blender indoors, perhaps. Anyway, you can kind of see there's different, each of these different configurations, each of these different designs is kind of promoting and inhibiting different quality attributes. They all do the same function, right? But this is ultimately what's determining the direction that we'd want to go. All right, the last big idea from Design It was these design methods. So at this point, like you would, kind of have the design thinking kind of ideas in place. We have some foundational knowledge. How do you do design? What are some things that designers actually do, that architects actually do? The way I've talked about this frequently is as a silver toolbox, right? And this This phrase comes from one of my mentors that I think really sums it up pretty well. Mel Rosso-Yopart. He said one day in class, like, "Hey, I can't give you a silver bullet, right? But I can give you a silver toolbox, a collection of ideas, a collection of methods that together can perhaps help you kind of gain orders of magnitude improvements in how you're building software." And that's kind of the spirit of what this silver toolbox idea is all about. It's a collection of methods that together are going to help kind of boost you, take you to the next level. The stuff in Design It is meant to be a way to start your own toolbox, right? Here's a collection of things that seem to work pretty well. Try some of them out, right? Start building out your own, collection of methods. Ultimately, like the goal of the toolbox, if you have enough of these different methods in your toolbox here, you can kind of pick and choose the right tool for the job when it's needed, right? You'll just have something ready to go. All right, here's one example that I like: round robin design from the explore mindset. So with round robin design, what you're doing is everyone on the team gets together and they sketch an idea, right? They might sketch an architecture they're thinking of or a design they're thinking of. You then swap your papers, right? Everybody trades papers. The next person is going to critique that design in some way. Like maybe there's some things missing. Maybe you have some questions. Maybe you just disagree with certain things that are in it, right? And then as a last step, you swap one more time. And the final step here is that you would enhance the design. So you now have in front of you an architecture, a design that is not yours and that someone else has evaluated. And now you are going to try and improve in some way. Okay, you're going to try and address those questions or comments in some way. Okay, wrap it up. To wrap it up here, you would then discuss these things, right? So this is a way to quickly generate ideas about whatever it is that you are perhaps talking about, and then converge back again on what's going on. This is a fantastic little workshop, very simple idea, but applicable in a lot of different situations, right? So architecture, database schemas, API design, lots of different ways you can use it for exploration. But you can also use it to check alignment, right? Is everyone actually thinking about the same things, right? You're going to see right away when everyone sketches, if instead of exploring, you say everyone sketch our architecture. As soon as you trade, you're going to know whether people are thinking about the same things, whether everyone is kind of on the same page. Okay. Fantastic little method for onboarding. You can do this just for fun, right? For teaching people new things about the design. And especially if you're having disagreements or if you need to create space for more discussion, it's a really great way to bring in and make sure that everyone can be heard. Okay. Yeah, fantastic little method. Oh, and here's some examples. So I guess back in the days when we were still in the office, actually moving paper around, might have something like the one on the left there, where each color is a different person who's kind of come in and added something. Okay. These days, a lot of stuff is done more virtually, right? So the Miro board is the same. That's the same workshop, just in a Miro fashion, a digital whiteboard. Okay, last bit here, whole team design. So it's been, I don't know, a couple of years, 5 years, 4 years since Design It was published. I think this idea is still very true, right? And I think that the principles, the mindsets, the methods, the foundational ideas, that brings a team together so that everyone is kind of contributing to design. That's really where the whole team design idea comes in. Something I'm curious about, though, is if we can do this well on teams, which I've seen pretty consistently, for the past 10, 15 years or so, what happens if we turn this idea up to 11? Can we apply these things at an organizational level, teams of teams, things like that? I believe Owen Woods was speaking of the book club a couple of months ago, shared some of these ideas around how the evolving role of the architect is contributing to different ways of making decisions, and may have talked about the sort of traditional idea, the traditional architect's role of defining, their role is to define the hard rules that people must follow. Developers then are open, to anything that's not defined, right? Whereas more kind of modern state of practice is architects are sort of fewer hard rules, right? Keeping things a little bit more open. A lot of kind of guidelines or suggestions that are created in collaboration with the development teams. And then after that, everything else is left open. These are fantastic ideas. I really like Owen's work, and I think this makes a ton of sense. At the same time, though, a question I have is, how hard can we push these ideas? What if we, have the whole team design concept extended all the way through the org, where, there probably still needs to be hard rules. We certainly are going to need suggestions and guidelines. And any other kind of aspects of the design are still left open for downstream of the architecture decision making. But what if it was developers everywhere? Developers are the architects are the developers across the board. Is that even possible, right? So with this kind of a thing, instead of looking at the organization as kind of a hierarchical, top-down approach, we need to be thinking about things in terms of decentralized networks, right? So kind of a mesh of architects in a way. The architect's role becomes kind of integrated, and you're going to have developers kind of self-managing their architecture in some way, because there's not a single kind of architect anymore. The role itself of the architect becomes deconstructed kind of into micro roles that are spread across this entire network. People are constantly kind of accepting and releasing these architecture responsibilities amongst the entire org. The way we would think about process or structure within the organization would be completely different, right? Instead of having centralized authorities where we're bringing people together, figuring out ways to kind of enable collaboration or just-in-time communication, effective decision-making when there is no single authority. And certainly there'd have to be things around maturity, grace, these kind of design skills, making sure that those are completely available across the org. This definitely works on small teams, right? All this idea totally works on small teams. And I don't know, can it work at an organizational scale? Can it work at a large organizational scale? This idea of a distributed design authority is, I don't know, something I've been working on for a while, but it's become increasingly interesting recently. So if you can pull this off, kind of the theory of this thing is your whole organization would be basically operating like one giant brain, right? Where every person is kind of a node in the network, providing information that is going to improve the architecture in some way. In theory, it means you end up becoming even more resilient to change, making even better decisions, self-adapting over time, right? Because there's no kind of single points of failure, and there's no bottlenecks in that way. Okay. Kind of moving from a centralized top-down, to a fully kind of distributed authority. All right, how could you actually pull this off? I think this is the stuff that we would need to do something like this. So getting sort of your organizational purpose in order would be important, right? So we talk a lot about business drivers and quality attributes. Yes, that's important, but there's more to it, right? Like getting deeper into like the why we are here, almost existential kinds of questions about the organization. Self-management principles, I think, would be absolutely key. If we can't self-manage effectively, there's no way we'd be able to decentralize and distribute these authorities. So a lot of this plays into, this is a smattering of the types of things that I think are needed with this. So consent-based decision-making frameworks, solid feedback mechanisms, the ability to share constructive feedback and receive it, conflict resolution processes, right, that are able to be handled peer-to-peer. yeah, open access to data and information, right? You can't expect people to be making decisions in a decentralized fashion if they don't have all the knowledge that they need to make those decisions. I already mentioned this, the essential skills and knowledge, right? Design it focused on really just that one piece, the essential skills and knowledge. It's foundational, right? It's necessary, but I don't think it's sufficient if you really want to start scaling up these types of ideas. The third piece that I think is needed is this idea of kind of this wholeness. You have to kind of really embrace this idea of an integrated mindset, code and architecture, not, you know, code or architecture, right? Programmer and architect, not, you know, either or. You can be both at the same time. Really getting into reflective practice as kind of a thing that just happens all the time across the organization. Getting into kind of, I guess, sort of more squishier human types of ideas, building trust, making sure there's strong safety, being willing to have vulnerability within your organization. That's going to require coaching, right? It's going to require support to do well, and it's going to require slack. You're going to have extra time, right, for being able to forge these bonds and you know, have those types of discussions happening. Time for healing mechanisms, you know, refactoring, healing the code, but also things like time off, healing your mind and body as well, potentially. All right, a little bit far out there, and I guess I should mention I'm still playing with these ideas. So if you have feedback or thoughts on this stuff, I would love to hear it. But also, please be gentle with me. Like, I'm exploring these ideas and find them interesting, but it may not actually make a ton of sense to be doing. So yeah, is this even a good idea? Who knows? It certainly seems interesting. The experiments that I've been doing at Kiavi at my organization, they seem promising, right? Things have been going pretty well so far, but I will tell you, it's been a journey, right? This is challenging. It's hard. It might not even be a great idea. It certainly does not apply to every organization. If you're trying to optimize for things like resiliency or you know, speed of decision making under extreme uncertainty, things like this might be interesting to be thinking about. If instead you need like strong predictability and intense, you know, safety, perhaps things like this are not going to be the things that you're going to want to do. Kind of a cool way to think about this, though, is the very same skills that you have as an architect and as a designer are the same things that you would apply to your organizational design potentially. So yeah, I don't know. I'm exploring this, and I guess if you are too, let me know. It'd be cool to compare notes. All right, if you're interested in that particular topic, here's a lot of the things that I'm pulling from for inspiration and for learning that I would recommend if you want to learn more. So Brene Brown stuff on kind of the resilient organizations and safety and learning cultures is pretty crucial. Reinventing organizations is really the kind of getting into the self-management principles, which I think is key for this kind of stuff working. And Jürgen Appelow's work on Unfix and Managing for Happiness, Management 3.0, he's kind of been at the forefront of these ideas, although he uses different words for it. You know, looking beyond kind of classic management kinds of approaches, traditional management, to, you know, the possibility of things that could be very different. So check those out if you're curious in those things. If you just want to stick to architecture, which is also cool, architecture and design, here's some books that I would recommend on those topics, right? So maybe from, what is this, the right to left here. For me, I came from the Carnegie Mellon kind of architecture tradition. So software architecture and practice and documenting software architectures are kind of the, you know, the canon, if you will, for the Software Engineering Institute kind of thread of software architecture. So those would be two books to definitely check out. They go into quality attributes and tactics, architectural styles, and a lot of the decision-making types of things in significantly more detail than what's in Design It. Software Systems Architecture by Nick Rosansky and Owen Woods is an absolutely fantastic book, very practical and great read for practicing architects. So it's building on a lot of the theoretical principles and being very specific about things to do for especially for enterprise scale kinds of large organizational scale kinds of architecting. Just Enough Software Architecture by George Fairbanks is also a fantastic book. This one, the big takeaway on this one is risk-based design, right? So knowing where to focus your time, knowing when to stop. How much design should you be doing? Okay. George's book is really all about that and more, but that's like the really key thing. And then finally, I like recommending these books by Gordon Glegg. They are older books, and these are more about design itself rather than architecture. They actually have nothing to do with software. They're fantastic books about how to design, how to think about design, framing design problems. There's a series of probably 4 or 5 of them. The design of design and the selection of design, they all kind of into that of design thing, the science of design. If you're curious about those topics, I think Glegg's books are really fantastic for for learning more on those. And he's absolutely hilarious, the stories that he shares from his past. So you should check those books out. Well, that's what I prepared today, and I guess I went a little longer than I perhaps expected to. But if there are any questions or thoughts for discussion, I'd be happy to stick around for a bit.
Hi, Michael. Lots of interesting points. Thank you for the recommendations, the book recommendations. We have indeed 4 questions in the chat. I will read it for you. One question from Miguel. What design documents are needed for agile teams to maintain efficiency and collaboration?
Sure. So let's see, for agile teams. So the let's see, my opinion before, I guess, in the before times was you can get away with very little kinds of documentation, right? When you're co-located together and everyone is in the same space, you can tend to rely heavily on kind of cultural artifacts that are kind of in the space. So the whiteboard that happens to be up in the room, very, what is it, the architecture haiku, right? So kind of one pagers, things like that. I think are, keeping it light. We're keeping it very lightweight. ADRs, right, are fantastic. Since moving full remote over the past few years, those kind of cultural artifacts are harder to come by. I think so you have to be much more intentional. So I think you have to be even for teams trying to keep it light. A lot more documents, I guess, is the way to go about this. So ADRs are probably the number one most important that everybody probably should be doing. If you're not probably, you should be writing ADRs. We've been experimenting with this idea of we call them design gardens or architecture gardens. So imagine a Miro board, right? A digital whiteboard that's just always available, and it kind of over time kind of slowly accumulates a lot of the design discussions that are going on. That requires curation, right? Because it grows unwieldy pretty quickly. But I don't know, we're trying to bring back some of the kind of things that were in the room with us when we were all together as a team to the digital world. And then, I don't know, greater emphasis on more traditional kinds of documents, but keep those templates lean, keep them very light. They don't need to be, huge, lengthy things.
All right. Second question is from Maria. What are some of your go-to design methods? Cool.
So let's see. I shared the Design Studio very briefly today. Design Studio is fantastic. Or sorry, that round robin design, I should say. The Design Studio is kind of that's one activity that you can do within the Design Studio. any kind of like, well, I guess we talk about this in terms of like some mindsets. So sketch and compare is a great kind of evaluation mindset. Risk storming is something from Simon Brown, which I think is fantastic. If you need to really dig in and evaluate something, that's you kind of sketch an architecture, and then you get kind of sticky notes on the board for things that are you perceive as being risky. There's lots of variants of that one that you can do. What would be a make kind of mindset? An understanding one. Stakeholder mapping. I surprisingly use that pretty often, especially at the beginning of projects, but also in the middle, because we end up forgetting who our stakeholders are sometimes. So stakeholder mapping is a pretty good one as well. I don't know. There's a couple of go-tos.
All right. Thank you. Uriol is asking, when you lose control of the architecture, if everyone is doing the architect's work, how do you maintain consistency and avoid bad decisions?
Right. So that is, how do you avoid consistency and bad decisions? So let's say just on the team, right? So within your team, everybody is kind of contributing. Everyone's playing a role. No one person is really the architect. Maybe you have a tech lead, but the tech lead is kind of taking maybe a step back from this. It's a risk. You could absolutely make bad decisions, or the architecture could evolve in ways that you don't quite expect. And that risk kind of increases, as you kind of spread these ideas out, perhaps, to the whole organization. It feels uncomfortable because as architects, we want to be really controlling these things very, very strictly. We want a lot of certainty. But those mistakes that we might be making, you kind of have to look at it from a longer term, bigger picture perspective. Most of the time when folks are making mistakes, they are not the types of things that are, end of the world, right? Types of things, right? It might be inconvenient and it might slow you down a little bit in the short term, but you're going to eventually recover from it, right? The lessons that you learn, right, from those types of mistakes, like that's the kind of thing that from a long-term organizational perspective, that's what you really want. That's where your kind of resiliency starts to come in. That's how you grow skills, right? You have to if you want architects, you kind of have to let people do architecture. And part of doing architecture and part of learning is sometimes messing up. So rather than kind of focusing on preventing these things, detecting them when they happen, designing the architecture, designing the system to make it okay to experiment, right? So I don't know, microservices is a cliche at this point, but frankly, it's really good at that. I can not be so worried about the how any one microservice is architected, right? It's relatively isolated. We have abstractions in play. Even messing up a small kind of local arrangement of services isn't that big of a deal. It's not going to risk the entire system. So those are all kind of creating opportunities, I guess, to lower the risks and letting people make those mistakes, letting people learn and do these things.
All right.
All
right. Yeah. Boris is asking, will you share this slideshow? We'll talk about it with Michael afterwards. For now, you will have it on YouTube, the presentation, so you can check it out there. We'll talk about that with Michael later. And I have the last question for you today, Michael. Is there any plans for a second edition of the book?
I'm not sure, actually. So this question has been coming up increasingly frequently, which I think is interesting. The one thing I recognize with the book is there was definitely it's very co-located centric, right? So I think if there are folks that are interested, like I would be interested to know if this is a thing that people are curious about or would like to know more. The methods, I think everything is still very applicable, but the assumed mode of operation is in an office, which I think is very, I don't know, it's accidentally become a bit of a time capsule in some ways, which is interesting, but also maybe something that could be improved. So I don't know.
All right.
If there's curiosity or interest.
Yeah, sure. Thank you very much for your time, Michael, today. It was a pleasure. We hope to see you again. And thank you very much for those who participated, and have a good day.
Excellent. Thank you very much.